Hey, came back for more. That means a lot. We are doing learning card number 7. And we're going to be talking about key information on graphs. Now, again, the crazy part here is all of this stuff, whenever I go through this, students are always saying, hey, we already know all this. This is so easy. And then they go along, and on a quiz or a test, everything gets wrong. So we thought it would be valuable to go through here, highlight all the important steps, all the important parts, and then let you guys loose. So, as always, defer to, if you're outside of West Chicago High School, defer to whatever your teacher says. So you may want to go in or pull it out of your book if you have one of those, but this should kind of get you at least to a usable format. So, x-intercepts. X-intercepts is the place where the graph is where the graph, might even want to say curve, crosses the x-axis. So here's my x-axis. Labels got covered up. I thought having these little cards on the learning cards was cute. Apparently not as much as I had hoped. Anyway, we always write our x-intercepts as points. Okay? And so because of that, you're going to look for places where these things are crossing the x-axis. So here's one. Here's another. So this would be your first x-intercept. We have an x-intercept at -4, 0. Some teachers, at least from the students coming into my class, have always like, oh, just, -4 is fine. And like this one over here, we're going to have to estimate this. My apologies, I didn't plan out this one as well as I probably should have. We have an x-intercept at let's call that about 3.9, 3.8. But anyway, so it's a point, and when kids start, when you students just start listing off like -3 or -4 and then 3.8 and stuff, it gets all loose. And I found that if you list it as a point, life is much, much simpler. And secondly, right over here then, now for your y-intercept, it's the exact same thing, except now it's going to be where it crosses. It's where the graph or curve the y-axis. So again, highlighting it. Again, we're going to have to estimate this because apparently my planning, I designed this last night. It was apparently later than I thought it was because I was pretty sure we had nice points all the way across. And then I adjusted some things, and here we are. But again, this is, actually, let's do this. It's going to look like 0y for there. Here, it's going to be x, 0. So notice, at least on the x-intercept, you have a 0 as your y point. Because everything on my x-axis, everything through here, has a y value of 0. And likewise, here, because everything on my y-axis has an x value of 0, my y-intercept is always going to end up having a y or an x value of 0. So if the y-intercept, the coordinate goes in the y section. For the x-intercept, the coordinate goes in the x-intercept, or in the x coordinate. Anyway, so back here, so my y-intercept here would be approximately 0, and it's not 1.75 yet, so let's say 1 point. Actually, that might have been 3.9 down there. My apologies. So let's say 1.7. I know you've expected better of me. My minimums and maximums are right on. Those were the ones that I ended up having to adjust things for. So speaking of minimums and maximums, when we're talking about this, maximum and minimum is the highest possible point on a graph. Not all graphs have them. So for example, if you had an arrow going off somewhere and it was going off to infinity, I'll show you this with the minimums in a second. We're not going to get into relative minimum or maximum for those of you guys coming in from outside of our school. We're just talking basics here. So in this case here, we'd be looking here at a maximum of, let's get a different color right here. So that's your maximum. So we have a maximum at, and then you just label out the points, -2, 3. It's the highest possible value that we have. Ta-da! It's not hard. Now for my minimum, again, we're looking for the smallest or the lowest point on the graph. That's probably a better way to say it. I'm going to scroll this down here for a touch. Now, just to be clear, let's say, oops, I don't want the creative pen. Let's say we had an arrow down here. So that means that this graph continues to go on infinitely down to the bottom. This graph then, maybe we even have one over here, that means that this graph would not have a minimum. It is possible for that to happen. Okay, it has to be, we're just talking about absolutes here. So we're going to say, all right, we need to have a really, really good minimum here. Now, in this case, we do have them because we don't have any arrows. And maybe right here. So we have a minimum or a min at, in this case we get 5 and then -3.25. That one is at least nice. And again, the reason why those are important is that if you were doing these stories in context with a real-life adventure problem or word problem, however you want to say it, oftentimes the most exciting things happen at the minimums and the maximums, because it's going to be the biggest, the most money, the fewest number of dog bites. I mean, whatever the context is, that's going to be very, very important. And that's why it's important to be able to recognize those. Increasing in interval and decreasing intervals. Again, you might be sitting there going, that sounds pretty interesting. Okay, it's pretty straightforward. The thing to remember is that these are from right to left. Sorry, from left to right. Dang it. I really should start over. I apologize. So an increasing interval is any place where as x gets bigger, I'll write it out. You guys deserve that. As x increases, y increases. And that definition is important because on the graph, it's pretty easy to see increasing. If you're doing this from a table, and if all the points were in order, it's good to remember that x is getting bigger and y is getting bigger. And the decreasing is just the opposite. So as x increases, my handwriting today is not where it should be. So as x increases, y decreases. So that would be going downhill like that. But again, if you're doing this in a table, it's again good to know that they're moving in opposite directions. So if you're looking at a table of values, if x is getting bigger, y is getting smaller. If x is getting bigger and y is getting bigger, then you know it's increasing. So in terms of writing these down as an example, so example from above, any place that's running uphill is going to be an interval where you're having increasing. So you can say it again from a starting point to a stopping point. You could either do it in interval notation, or you could simply just say, like here, I could say from -3 is less than or equal to x, which is less than or equal to -2. From this point here, this is an increasing function. This function is, this graph, excuse me, is increasing from between -3 and 2. It's decreasing. Notice here, it's going downhill here. And so, an example for decreasing would be from -2 is less than or equal to x, which is less than or equal to 1. Same idea. Now again, you could do that in interval notation. So again, you could do, if your teacher taught you this, you can do it that way too. Okay? Last thing, and again, this seems a little sticky here, but you just got to be careful. So when they ask you to evaluate something, so like here when x equals 3, and I know you're saying, why do we need to know this? Because I already know how to do this, and I always do it, and then people miss stuff. So again, so when x equals 3, this is the point right here that we want. So it goes to the point 3, 2. So when x equals 2, y is equal to 2. So it's a point on the graph. Now the interesting thing here too is if we back this up, you can also have this in a variety of different backwards ways too. So like here it says when y equals 1. The part that people tend to miss up here is that, so here's y equals 1. Let me do that in a different color. Oops. So when y equals 1, we are going to pick a nice color here. You're going to actually run all the way across. So in this case, we actually get 3 different values. Oops, that's not the line that I want. This is the one that I want. So you're going to actually get 3 different values here. So I've got one here, I've got one here, and I have one here. So you actually, a lot of times people will end up just not going far enough on this. So like in here, I get an x value could be -3, x could equal 1. I could also get x is equal 2. That would be about what, 3.6. So you have to be careful because you want to go through because, it could be a height, it could be time, whatever. So just make sure that you hit and be thorough enough with this. The biggest piece of advice on stuff like this is, especially if you feel somewhat confident about it, is just slow down just a little. Not a lot, but just be, I guess would say, be a little bit more intentional in doing it. And that alone can save a lot of interesting mistakes. So, I will talk with you soon. Catch you later.